Today we're going to talk about limits. And before we talk about limits, we need to know what the definition of a limit is. So many mathematical problems involve the behavior of a function at a particular value, and this is when we actually plug in the value for x given a function and solve for y. But the limit is the behavior of the function near x equals c rather than at x equals c, meaning we're looking to see what happens as we approach that value from either side. So here you're given a graph, and we're going to take a look at the value of the graph as we approach 1 from the left. So here we identify where x is 1, and we're going to approach from the left-hand side. So here we're approaching from the left. We come up to the value where y is negative 1, 2, 3, 4, and that is a solid point. So the value of y as we approach 1 from the left is negative 4. Now, when we approach from the right-hand side, we're approaching from this direction. We notice that this is an open circle, but since we're not evaluating the function at that value, we're only seeing what happens as we approach from the right. We are looking to see what we get as close as possible to, and in this case, it is where y is equal to 2. So when we are identifying the value of the limit as x approaches 1, we have to see the behavior from both sides. In this case, as I approach from the right, I get positive 2, and from this side, I get negative 4. Therefore, because these values are not the same and the graph totally misses each other, the limit in this case does not exist because the values from the left and the right are not the same. Okay? So to indicate the limit approaching a value from the right, we use the following notation. It's the limit of the function f of x as x approaches c within a plus in the exponent, which indicates that we are approaching from the right-hand side. To indicate the limit approaching a value from the left, we use the following notation. It is exactly the same, the limit of f of x as x approaches c, c being some given value, and then we have an exponent that is a negative, which means we're approaching from the left-hand side. Okay, so in order to evaluate the limit, okay, what we need to do first is we're going to practice using the calculator. So the first thing we need to do is go into our calculator, and we need to go into second table setup, which is window, and we're going to change the independent variable to ask. And the reason why we're going to do this is because we want to approach a specific value as we get closer and closer to, I don't know, let's say 3 or 5. If we just give it a specific value, the table automatically counts by ones. What we actually want to do is have it go to a specific value that we're looking for, so we can actually ask it. So we're going to go into y equals and clear out any functions that we have, and we're going to put in the function that we're given in 1a, which is the square root of the quantity of x minus 3, and then on the outside we have plus 1. Okay, so what we're going to do is go into the table, and you notice that this is totally blank. So what we want to do is we want to know the limit as x approaches 3 from the right of the given value. So we only want to approach from the right-hand side. So you notice here, if you're on a number line like this, if this is 3, 3.1 would be maybe right here. 3.01 gets closer, 3.001 gets even closer, and so on. So this is further away, this is closer to 3 with the decimal. So if I go into my calculator and I type in, I already have the function in there, and I type in 3.1, it's going to plug in and give me a value of 1.3162. Then I'm going to type in 3.01. When I press enter, I get 1.1. Now remember, these are your y values. When you type in 3.001, you get 1.0316, and then the last value with 3 zeros and a 1, you get 1.01. In order to evaluate the limit as x is approaching 3 from the right, what you're looking at is the trend of the values as you're further away from your x value and as you get closer. So here the value for y was 1.3. Then as I got closer to 3, it's 1.1. And then even closer to 3, it's 1.03. Here it's 1.01. If you were to throw another 0 in there, I can guarantee you this is going to get closer to 1. Go ahead and try it. But the limit as x approaches 3 from the right-hand side of the given function will be equal to 1. Again, you're looking at the trend and what happens from here as you get closer and closer to the value and from the side that you are approaching. When we take a look at example B, we want to do the same thing, but we need to change the function in y equals. So the first thing you want to do is go into the table and make sure you go to the top and delete each value, then go into y equals and clear out the function. To put in the absolute value, you need to go into math, move over 1 to numerical function. It's the very first option, absolute value. I'm going to type in 2x, and then I move over and divide by x. So what I want to do now is go into the table. So I'm going to go into second graph. I have the function in. Here we want to evaluate the limit as x approaches 0 from the right-hand side. So here again we're approaching from the right, but in this case we're approaching 0. This is further away, this is closer to 0. Okay, you could even put in 0.00001. Okay, but what we're looking at is the trend of our y value. So when we put in 0.1, 0.01, 0.001, 0.0001, I'm looking at these values, and these all came out to 2. This is pretty obvious. The limit as x approaches 0 from the right-hand side is positive 2. What you then want to do is go back in, because our question C is the limit of the exact same function as x is approaching 0 from the left, but now we're coming from the left-hand side. So if this is our number line and this is 0, we're now on the negative side, which is why all these values are negative. We're going to delete all the values. We do not have to go in and change the function. It's already in there, but we just want to type in these values, negative 0.1, negative 0.01, and so on. This one is also obvious because there are no decimals. We do not have to estimate. Here, the limit as x is approaching 0 from the left is negative 2. Where this will eventually lead us is that we have to evaluate the limit, as I showed you on the previous page, as x is approaching 0 overall. So we're looking at what happens as we're approaching 0 from the left and from the right. If we're approaching 0, which is right here from the right-hand side, we were up here at positive 2. So that meant my values were going in this direction. If I was evaluating the limit as x approaches 0 from the left, which is from this side, we were down here at negative 2. That means my values were here. So now when I look at the graph overall, as x is approaching 0 from both sides, is the graph meeting up at the same value? Because these two values are not the same, if I was asked to evaluate the limit as x approaches 0, just 0 overall, of the absolute value of 2x over x, the answer would be it does not exist, because these two values are not the same. Here, we're going to evaluate the limit as x approaches 3 from the left. So we need to delete all the values in the table, go into y equals and clear out the function, and we're going to put in the square root of 9 minus x squared. Okay, we go back into the table, and now we need to identify the values as we're approaching 3 from the left. So here's my number line, here's 0, here's 3. If I'm approaching from the left, values would be 2.9, 2.99, 2.999, and then we could have 4 nines. Here this is further away, this is closer to 3, so now when I put in the values, the y values that I get are 0.768, 0.245.077, 0.02449. Okay, so as I am getting closer, I could even put in 2.999999 5 times. What I'm looking at is the trend. What is happening? This is 0.768. This is 0.245, 0.077. As I am getting closer and closer to 3 from the left-hand side, the limit is getting close, meaning my y values are getting close to 0. You're looking at the trend here. So go ahead and evaluate this. Here, we are actually taking a look at what happens as x approaches 0 from the right. So we would take a look at a number line. Here's 0 for approaching from the right. We would consider maybe 0.1, then 0.01, 0.001. Start throwing more zeros in between the decimal and the 1. When you go into the calculator, see what happens here, but your final answer should be -1. These should be filled out. In the next examples on pages 3 and 4, I'm only going to evaluate using one graph. The other graphs you are to do on your own. So what we're going to do is take a look at graph A. By definition, the limit is if f of x becomes arbitrarily close to a unique number as x approaches that number from either side, then the limit is equal to that value. So what we're looking at here is, based on what we have, this is just a graph. We do not have the function. We're taking a look to see what is the limit as x approaches -1 from the right-hand side because our superscript is a plus. Okay, so we're going to identify where x is 1, okay, and we are going to approach 1 from the right-hand side. As we approach 1 from the right-hand side, here we're approaching 1, I get a value of 2.5. Excuse me, it's -1.